Hello and welcome everyone. Today, Min Feng is going to do a talk on essentially self-sovereign data. That's my understanding of it. And so, Min Feng, before you present your slides, could you tell us a bit about yourself, your topic?
That's good. So before we start this presentation, I just have some brief introduction about myself, as Peter said. So hi everyone, my name is Ming Feng, and currently I'm a PhD candidate studying at the Swinburne University of Technology. So my base campus is currently at Melbourne. So it's really my honor to be here to give you a brief live presentation about the research project that we've done recently. So the topic of this presentation is basically about the data sharing. So we have implemented a platform which is about the data sharing that we call it as a DeDa, a Defi-enabled data sharing and the trading system. So we also got this work have been published in a conference. I think it's a pretty good conference, and I also put it in the last slide. If you are interested in it, you can just have a look at it after. So yeah, I think it is a brief introduction about me. Oh, okay, I just forgot. My third interest is basically about the blockchain privacy and the smart contract security. And currently, I'm being cooperated with an industry company who is doing a digital wallet, and I'm basically to protect their security. So that's one of my interests. So without further ado, let's just get started. Is that okay, Peter?
Yes, most certainly. Please go ahead.
Yeah, thanks. So in this presentation, I will firstly introduce the background of the project and illustrate the contributions made in this work. Then I will briefly discuss the system model and the model evaluation part. Okay, so the background. I believe that there's a fact that we are living in the big data era. And every moment you can imagine there are massive amount of data being generated and collected from various data sources, right? Ranging from our mobiles to the IoT devices, from business logs to the social networks and etc. So the data has become an indispensable part of our life. And these collected data, I think they are very valuable assets because there are various knowledges and patterns hidden inside the data and just waiting for us or machines to mine and learn. So that's the key point. However, we have to realize that the data is either difficult or expensive to get in the reality. Because for me personally, when I'm doing some research and when I'm doing maybe I need to build some machine models, and I realized it's really hard for us to find the really interesting and valuable data. So that's a true part. I'm not sure whether you dig it or not, but for me, yeah, it's true. So while there are many reasons for that, and we just found that there are some following barriers, like the limit and discourage the data sharing. So I will just introduce one by one. So the first limitation that we found, like in the real life, is the lack of discoverable data. So the data owners don't know how to describe or publish their data for sharing. On the other hand, they don't have a uniform data category or repository to retrieve the required data. And the second reason that we found that there is a lack of incentive and fair data sharing. While the open data are always welcome and valuable, but they are strained by their size, their coverage, and the access control. So some companies and individuals may collect data in various domains and resell it at a higher price, which makes it more affordable for people like me to use the data. So that's the second reason. And the last reason that we found is the lack of open and trusted data market. So that's one of the motivation that we want to implement this project. Even though people are willing to, to compute their data or purchase data at a reasonable price, it's hard for them to find such an open and trustable marketplace to allow people to trade their data in an end-to-end way. So yeah, so that's the motivation. So so to drive the above those challenges that I mentioned, we just proposed or designed a centralized ecosystem where people can donate or trade data at the end for the public goods or maximizing the data value. So we just leverage blockchain as a decentralized infrastructure, and the ideas always come from it's come from a DeFi, because in the DeFi, people can autonomously manage their assets. So something like that. We just leverage this concept, and we assume like our DeDa can to autonomously manage their data assets. So that's the linkage between the DeFi concept and our project. So I know the people come for today is pretty much familiar with the concept of blockchain and DeFi. So I wouldn't, spend too much time on explaining what is a blockchain and DeFi. So basically, I'll just skip it and go to the next slides. So so the contribution, we just built a POC DeFi-enabled data sharing and trading system. So that's one of major contribution. And the second, we in our system, we build innovative elastic data pricing schema, because we know the data pricing is a very important component in the data marketplace. So we design a schema to that can dynamically adjust the data price with the demand of the with the data demand and the time decrease. So that's another contribution. And the third, we got it. We conduct some evaluation there, and this is the third contribution. Let me just so right now, let me just quickly go to this part, like to introduce our system architecture. We present our proposed model and describe the model working process from a high level perspective. So I won't go to too details like how it implemented. So that's the reason I just asked Peter why we the background of the people coming today. And there are five entities in our system implementation. One is the data providers. Those are the people who are looking to commercialize their data. So the users can post the data as a product, and by just creating a smart contract and filling the metadata according to the provided generic metadata template. So in our system, we already have a template for metadata template, and the people who want to sell the data, they only need to fill this template, and this quick and a very convenient way to publish their data. And the second component that we call is a data consumer. So those are the people who want to purchase the data that meet their needs. They can explore and compare multiple data sources collected in our platform, and purchase data via a very secure and fast method payment channel. The third component, where we call it is a smart contract. So basically, the smart contract will implement the business logic and the rules to govern the data transaction flow. So there are 4 modules written in the smart contract. that I will introduce later, which is about the price, delivery, transaction, and discovery part. Also, the blockchain, we just employ the blockchain as a decentralized infrastructure to substitute the centralized architecture in the conventional data sharing system. So that's the one of the characters of that we know with the blockchain as a decentralized infrastructure. And then finally, the fifth component I would call is a distributed file storage system. It's a off-chain storage approach that usually used to store and retrieve the data. So the reason that we don't want to store all the data information on the blockchain, because we know the storage cost on the blockchain is quite high. So that's why we choose the off-chain and the on-chain combination way to store the data. Okay. So our product, our DeDa, will connect the end users, which are seller and the buyers, but while not holding any data itself. We in this graph, in this figure, we just illustrate the end-to-end introduction of the data transaction, and basically it can be divided into the 5 steps. Firstly, about the data seller, they can do a action like to publish their data product. So the data product can be published by anyone who are able to connect to the Web3. They only need to fill the metadata as a described. So in the metadata, we have a couple of categories. So they need to choose one of the options, like what the data category and what's their imagined price to submit it. There are lots of forms they have to fill out and to describe their data products. And once they're done, they can just post it. They just click the button, and the data products will be published. So any transaction will be written into the blockchain, and once the information on the blockchain will be immutable and can be traced. And the second is about the data product browse. Is sort of for the data users. So the data users can browse various data sources, and they can search for specified data sources by using some keywords. They also can obtain some sample data. So that's basically the functions in the data browse. And then also once the users determine to buy a data product, they can just check out. So it's quite similar to the transaction we made in the Amazon or the eBay. So it's quite familiar with us. Let's check out, but different from that, we don't use, because we're using blockchain. So basically, we kind of now using some real credit card or other things. Instead, we can use some the cryptocurrency to pay for that. So there are 3 basic pricing options that we provided in our platform, which is about the one-off purchase, and the ongoing subscription, and the usage-based license. So there are 3 options when they can choose when they want to check out. And the fourth part is about the data delivery. Data delivery can be deemed as another important component, because the things about data delivery, is quite big, because you have to prove like the data sources can be secure, or can be data privacy issues. So the things connect to the data delivery is sort of complicated, but we are just to designing another secure way about the data delivery. So that we are now trying to use the key, a security key or private key to do that. But later on, we can have a discussion about data delivery. The last part is about data updates. As I said, we had implemented a schema about the data price. So I will do more details about that later on. Basically, data updates, like I will say, is kind of important because the price, like the user, as I said, the user firstly set up their price when they publish data, but it's not reasonable. The data price will be changed with the time or with the data values. So the data price have to be reflected the data value. So that's why we have implemented a schema about the data price. It's also a quite big aspect. Well, there are still a couple of things we cannot go to details due to time limit. So the remaining time, I would explain like more about the data price, this schema that we implemented. Okay. So as I said, the data price is a rather complicated problem. In order to reflect the true value of the data in the marketplace, we just proposed a data price schema, which include two parts. One is the initial data price estimation method, and another that we call is an elastic data pricing model used to dynamically to update the initial price set by the users. So I would like to compare with the data pricing method that take various factors in the current method. Like they always take the data value, the number of features, the precisions into consideration when they estimate data value. So it's kind of complicated. So but in our initial data price, we try to avoid such a complicated estimation. We just let the user data providers. We provide such a simple way, like to let them to roughly to calculate the data price, just using a data cost plus a margin as a price. So we have a formula that we made here. The P is the calculated initial data price, and the percentage of M is a margin, and the S is a parameter corresponding to the expected number of the transactions, and the C is the cost of the data. So by just using such a very simple, very clear formula, that the users who want to publish data can just employ this formula to calculate their the initial price. And but we know that the initial price, as I said, cannot reflect the real data value in the market. It's just estimated by the user itself, because the variable that we used is just determined by the user. So, but the price is largely depends on the subjective estimation. It depends on the estimation of the data providers, and it may not accurately reflect the market conditions. So let's just take as an example. So if the data price is much higher than the market price, it's unlikely to attract the potential users. So therefore, we have to design another way, which we call it is an elastic data price, to dynamically or adjust the initial data price to a real price that can reflect the data, the true data value. So in the second method, we consider two factors. One is the transaction, and another is a time. We call it is a entropy-based dynamic data price estimation method. So there are two parts, I said. The one is the transaction-based value increase. It's basically describe the impact of the transaction on the value of the data. So the overall trend between the two variables is positively correlated. And as the number of the data transaction increase, the value of the data also will increases. And the second, we call it is the time-based value attenuation. As the time goes by, the value of data is constantly decreasing while the data entropy continues to increase. So taking into account the different time values, we create a non-linear statistics model to describe the trend of the data over time. So you can see actually from the figure at the bottom, it just describes the time value. I mean the value of the time over the value of the data over time. So overall, just combining these two methods, first they set up the initial price and based on the time and the data demand, which is about the transaction, the total number of transactions. The initial price will be eventually to present a stable price that can truly reflect the data market and the data value in the market. So that's our design.
Yeah. So just looking at that formula, if I can ask a question.
Yeah.
So sum of S is the number of times people have accessed the data. So as you go through with time, if people want that data more and more, then the price would tend to go up. However, that entropy function is that thing there that with time it goes higher, which given it's on the bottom of the equation means that the overall price would tend to go down. So is that essentially saying the older data is, the less valuable it is, essentially?
Yeah.
Okay. Yeah. All right. Okay. That makes sense. So.
Yeah. So as I said, we implement our data marketplace, and we also do some evaluation about that. So about the evaluation part, we just test the performance of the system services, and we just visualize the testing result in various plots. So overall, most of the functions like we tested is satisfy our objectives in terms of the responsible time, the responsible latency in the bias throughput, and we also tested the functionality of the smart contract that we implemented. Basically, it's about the gas consumption, and also we got some outputs which are also satisfied. So I think that's all for my presentation, and I'm really want to thank Peter to give me such a good opportunity to present our work, to present our ideas about the data sharing. And I would like to talk to give a minute, there are some other future talks in the coming years. And you can see actually from December 7 and to the beginning of next year, we got more interesting topics, and I would like to share those topics to you guys if you can just join us. Also, we will publish our, I think that should be talked by the Peter, right? But yeah,
that's okay. Yeah.
I think that's all for my prediction, and. As I said, we just got our work published in some conferences. One is on the the ASM International Symposium on Blockchain and Secure Crypto Infrastructure, BSCI, is a Asia CCS conference, and another which is more details about the data delivery. As I said, we just use the data box services to deliver for the data delivery part, and we got it published in the ICWS. It's also a good conference. So if you're interested in this work, you can just have a look. As I said, yeah. Thank you, guys. Any question?
I think you're going to have a few questions.
Yeah,
I know I've got a few. Let's do it to people.
Hi, Minfeng. Just as a first question, can you talk more about the delivery module and like, for instance, is it on chain?
Okay. Delivery module. I think it's a good question. So it's not an on-chain. It's not an on-chain delivery method. Like, but the transactions made, like, for example, you are the buyer. You are the buyer, and I'm the seller. So the transaction we made will be recorded on the blockchain, but it's not, it will not happen like in the blockchain. So only the details of the transaction will be recorded, but we can have another way to build a secure and faster channel to make a payment like that.
So where is that user data actually stored?
I mean, you're talking about the transaction data or the delivery data?
Not the delivery, sorry, the actual transaction data.
The transaction data.
Yeah.
So so if you are to pay it by the cryptocurrency, definitely the transaction made, it will be stored on the blockchain. But as I said, basically, the common way and the easier way is just using the cryptocurrency to pay the data product that you buy. But if you would like to do another way, like the transactions, the data of the transaction can be recorded on the blockchain. So
and delivery data, is it on IPFS or something like that?
Yeah. So the real data actually will be stored on the IPFS or the MongoDB other database on the other databases. But there's a mapping with the real data and the data stored on the blockchain. So if you want to retrieve the data, actually, the data can be linked into the IPFS, and you can retrieve the data from the IPFS.
And what stops the person from then reselling the data as well?
Sorry, I cannot. Does
anything stop the buyer from reselling the data, potentially on other platforms or anything like that?
That's a really question. So if the people want to resell the data, we haven't figured out like how to prevent the users or the buyers to sell data, but it's a very good topic. So I would like to discuss with you guys, like if you have any discussion or any ideas with like to prevent the from reselling data, because I think it's sort of complicated topic, but it's really happens in our real life. Like maybe some of like what I know, like some method will put some IDs into your data or something like that. Yeah. So in our work, we haven't done such a thing, but it's really good topic.
Hey, Minfeng. I've seen companies use things like rate limits on API calls and that kind of thing to limit the volume of information on there. Is that something that you've taken into consideration, or once the user has made a purchase, are they able to pull all the entire data repository?
Yeah. That's one of the options. So using the API, like as I said, as I introduced in our data delivery, we got three options. One is the just buy it as once, so you can get all the data, and another is the license, for example, the 1 year license, or another way, like you can just based on the usage, like using the API way to control the data that you used.
Okay. I have one more question about the pricing formula that you have. So How does that take into account the volume of data? So for example, the value of the data goes down over time, but if the data was collected over 40 years, 50 years, I think the size of the data or something, for example, I was reading something about mortgage information. If you had like mortgage insurance information, and over time, you could kind of see certain trends, and with different counties and that kind of thing. How does this formula take into account like the volume of information and and contexts like that, where like the newest information wouldn't necessarily be, it maybe the last year would be valuable, but collectively, the collective information in and of itself would provide more insights, especially for forecasting or seeing outliers within the data.
Yes, it's a very good idea. Like in our formula, we only consider two factors. One is the time, and another is the demand, or can be deemed as the transactions. So let's just take a user, for example. Like I have a data product. Let's say in this year or in this month, my data product was bought like by 10,000 times. So the demand that we can see is quite high, right? So we can deem as the value of the data will be high. But after months, suddenly nobody come to buy the product. So definitely the number of transactions will become zero, but the time will goes up. So the value of the time will goes up. So the value of the data will significantly decrease. So that's why the data value itself will be decreased as well. Did you get what I mean?
Yeah, that makes sense.
Yeah.
I've got a question related to it was a slide before this. Maybe there was a sequence diagram.
Okay.
And I think it's going to be sort of indirectly related to that one there. So we've got this delivery module, and it, I believe, is on chain. And anyway, we go deliver private key. And so I assume that, I'm not sure. So is that private key for encryption or?
Yeah.
That doesn't look like it. That looks like a very bad idea.
So
So if the data consumer publishes a public key, say on the blockchain, they could say, hey, this is my public key. And then the data provider could encrypt data against their public key. So the data provider controls their private key, data consumer controls their private key. We don't have a private key in the cloud or on the blockchain or anywhere. Does that make sense?
Yeah, definitely. Yeah, true. That definitely is true. Like many, because I have been taught this project. I mean, this overwork in many things, and this is question often just asked by the others. So we have the reason that we want to explore the data delivery in another work, because we just found this way. I mean, just deliver the private key this way is definitely insecure, and it's not it's not it's not supposed to be happen like just deliver a key for the data delivery. But in this work, because we have published this work, and in that work we haven't we just partially implement this data delivery module, so we haven't considered like too much details about the security. So that's why you got this figure in this side, but definitely in the real implementation we haven't done that. We haven't do such a thing like just deliver secure key.
Yeah, okay. All right. And I think that then that covers Lecky's question as well, at least question 1 about IPFS is public, so that you're going to need to at least encrypt the data. Though even encrypting data that is, like has long-term security ramifications, if it's anywhere that people can access, then, like if there's some as importance from now until say 2035, and if the encryption methodology is breakable, say in 25 years, that data would be exposed. So if you thought quantum cryptanalysis was going to be a thing, then that'd be a problem. So even storing encrypted data on IPFS could be a problem if it's information that you need to keep secret. Lecky also said, I suggest could also tap into DID, so decentralized identity. That way people could retrieve access to the data repeatedly.
Yeah, thank you.
Yeah, all right. And then Hayden's talked about encrypting data. Okay, are there any other questions?
I have one more question. So using let's say there was a decentralized mortgage, just going back to that as an example, and I wanted to be able to show the payments that I've made. Let's say the mortgage is a 30-year, we do 30-year mortgages in the States. So let's say I wanted to prove that I made those payments on time over a period of time, but then the person who's purchasing the data is looking for maybe there's some demographic information, some location information, some, like where the property is located and that kind of stuff. But the person who's purchasing the data is looking for collective information related to, so they want to see all information related to mortgages within a certain geographic area. Is there a way to aggregate that so that way when they're making the purchase of that information, they're basically purchasing in bulk, but paying out to every single individual who provided that information? Is there a way to batch purchase the data from a collection of users that fit a certain criteria that the user, that purchaser would be looking for?
You'd have to have metadata then, wouldn't you? Associated with the encrypted data, so that then you could group data into a data set. I don't know, Minfeng, I'm answering, I'm just thinking out aloud, but that'd be the only way to, because if you've got everyone publishes essentially encrypted data, then you're not going to be able to dive into it.
I think I cannot figure it out, but it's really I think it's a really good ideas or good terms, like we can think later on.
I think it would be interesting to be if there was a way to be able to batch, because right now, and this is something going back to the States, there are data brokers in the United States, and they sell our information without our permission all the time. And you can buy them from these marketing firms and that kind of thing. But like, I understand the need for the companies on the other side to want to collect that data to better understand their customers, to better understand trends and that kind of thing. But if there was an opt-in way for individuals to say, yeah, I'm comfortable sharing this information because I know, I know where it's being used and why it's being used in such a way, and that kind of thing. So if people could pool together, not necessarily like, getting together and say, hey, let's pull our data and add it to the marketplace, but individually selecting what works for them and what information they want to share. So that way, the person or entity purchasing that data is able to then, through different filter criterias, pull that information in and say, okay, now I have a nice data set of maybe 100,000 individuals with, you know, these different parameters. Maybe it's shopping patterns, maybe it's bill payments, maybe it's, you know, whatever it might be. And then from there, you could run different types of analysis in a way that's, you know, doesn't violate anyone's rights, but still allows the user to retain control of, you know, or the person contributing the data to retain control of their information.
Yep. Yeah, and Hayden's got a great little thought in the chat for those people on the video who won't see it. Completely agree, Ruud. People are willing to sell their medical data for search, but not for insurance purposes, for instance. You can probably think of as like situation for almost any personal data. Or for research, for data, yeah, medical data for research. Yeah. 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 So look, Ming-Feng, thank you for your talk. Generated a lot of questions, a lot of thoughts, so a lot of things to think through. So good luck with the rest of your PhD. We look forward to hearing about you being a doctor. And so thank you again, and talk to everyone later. Bye-bye.
Bye. Thank you, guys. Thank you,
Everyone, thanks so
Bye.
much.